When Galileo first gazed through his telescope 400 years ago, his discoveries changed the way mankind saw his place in the universe. For the first time, he was able to observe craters and mountains on the moon. He discovered 4 of Jupiter's moons and proved they orbited the giant planet. He was also the first person to view the rings of Saturn. Today, while optical telescopes are larger and more powerful, they are still constructed using the same principles as in Galileo's time. But as we peer deeper into the universe, interstellar gas and dust interferes with visible light, blocking our view into the past. One solution is to change how we look at the stars. Instead of using visible light, astronomers can use one type of invisible light, infrared radiation, to study the heavens. With its longer wavelengths, infrared radiation allows us to gaze deeper into the universe and farther into the past. Soon, astronomers will be able to use the world's largest and most powerful airborne infrared observatory to make studies bearing on the questions: how did the Sun and Earth form? And what conditions led life to start on Earth? The Stratospheric Observatory for Infrared Astronomy, or SOFIA, is a specially modified Boeing 747 SP aircraft housing an infrared telescope assembly that weighs 17 tons and has an 8.5-foot diameter mirror. The flying observatory is designed to detect the formation of stars in our galaxy, determine the chemical composition of the interstellar medium, and peer through the dust that hides the black hole at the center of the Milky Way. SOFIA will fly between 41 and 45,000 feet above sea level, which is above 99% of the water vapor in our atmosphere.
The water in the atmosphere absorbs infrared, so we got to get above that water vapor, and that's why we put the infrared telescope into the back of the 747 so that we get up into the stratosphere where there is no absorption by the water vapor.
However, mounting a 17-ton telescope assembly in the tail of an airplane presented an engineering challenge. A 16-foot-high hole was cut into the rear fuselage of the aircraft, and doors were installed to protect the mirror when not imaging the universe.
The modification itself is rather extensive in that there was a very large hole cut in the back of the airplane. The hole that was cut was about 4 by 5 meters. It's the largest hole that I'm aware of that exists in any 747. This made a bump on the airplane where the doors cover this hole, and that we have to verify that that bump hasn't caused additional drag that would preclude us from being able to meet our time requirement at altitude, and also to verify that the stability and control characteristics of the airplane haven't been influenced or affected by this modification.
The telescope was built by NASA's partner, DLR, the German Aerospace Center. Astronomers hope the size, sensitivity, and versatility of the observatory will put SOFIA in the rank of one of NASA's great observatories.
Capital G, capital O, Great Observatories, is a special designation that NASA has reserved to 4 separate observatories. The Hubble, which is a visible telescope, Chandra, which is an X-ray telescope, the Compton, which is a gamma-ray telescope, and Spitzer, which is an infrared telescope. SOFIA is certainly a major NASA observatory in roughly the same category of those that is capable of doing great observatory class science.
Unlike space-based observatories, mounting a telescope in the back of an airplane offers several advantages. One is the ability to quickly position SOFIA anywhere in the world to observe the night sky. The second major advantage is that SOFIA comes home after every mission. Scientists and technicians will have the chance to add or replace instruments in order to adapt to changing astronomical events and new technologies. Technicians will also be able to repair any necessary parts and replenish supplies. Because of this flexibility, the projected lifespan of SOFIA is 20 years, while space-based observatories typically last between 5 and 10 years. SOFIA is currently undergoing flight testing at NASA's Dryden Aircraft Operations Facility in Palmdale, California. NASA Dryden is responsible for the aircraft's technical operations, while the science program is overseen by scientists at NASA's Ames Research Center at Moffett Field, California. Flight testing is currently scheduled to continue this year, with science missions beginning in the spring of 2010. SOFIA will be a key component of NASA's astrophysics program, answering fundamental questions about the universe. The capabilities of the aircraft and the telescope offers researchers a quantum leap forward as they explore the hidden universe.